So, today we are going to discuss comb tying diagram. In this slide you can see the depiction of the combing process. As you all know that we have to feed the lap, then that will be a combing operations. Once the combing is over, then we go for detaching of the comb fringe, and then we collect the fringe and try to make a sliver by arranging the fringes in a specific manner and combining them together. We will learn about them later on. Once the sliver is formed, it goes for drawing operations on the drafting unit, and once the drawing is over, then we go for packaging. That is, we have to make a package of the sliver that we produced on the combing machine. Here there are certain operations in the machine which are performed in a cyclic manner. Let us see which are those operations. If you look at this slide, then we see that the cycle of operation consists of quite a few sub operations, and these are lap feeding, cylinder combing, top comb penetration and withdrawal, nipper movement, and detachment, that is detachment of the comb fringe. Other than this, the further sub operations under nipper movement are nipper oscillation, which you have already learnt earlier. The nipper has to move backward and forward, and there is another thing that we do, that is nipper plates, they close and open in order to grip the lap sheet. So, there has to be these two operations also. Similarly, for detachment we have forward rotations of the detaching rollers and backward rotations of the detaching rollers. Other than this, under cylinder combing we have another operation called cylinder comb cleaning, that the that the cylinder comb consists of large number of needles on its surface, and the needles they get filled up with lot of fibers, and you have to clean them also. So, these are the various operations which we have to perform while going through the combing. So, the operations must take place in a specific sequence. The operations repeat in a cyclic manner, and one set of operations constitute one cycle and the cycle repeats. So, we see there are so many operations which are there. All these operations need to be performed in a particular or specific sequence. So, the question that comes to our mind, how do I set the machine so that all these operations can be performed in the desired manner? It is not that we cannot have those operations arbitrarily, that one could be done any time with respect to the other. They have to be performed in a very specific order, and for this what we have to help in setting the various operations relative to each other, we have a wheel which we call index wheel. On the index wheel, which is shown on the left hand side, you see that this wheel have marks on its periphery starting from 0 to 40, and these are known as index numbers. So, the periphery is having numbers starting from 0 and it goes up to 40. The wheel facilitates the setting of the machine elements corresponding to various operations. The wheel is also mounted on the cylinder comb shaft. So, one revolution of the cylinder comb shaft or the cylinder comb basically means one revolution of the index wheel, and the marks are read against a pointer, as you see it here, the pointer fixed on the machine frame. So, on the frame this pointer is fixed, and this wheel which is fixed on the cylinder comb shaft can be turned. So, the purpose of the index wheel is that it facilitates setting of the various machine elements corresponding to various operations. Now, we will go to the next slide and try to understand it further. The first operation that we are going to discuss is timing of Nipper oscillations. Now, you must be remembering that the Nipper assembly is made to oscillate backward and forward continuously. So, to avoid collision between the cylinder comb needles and the detaching rollers, combing is to be carried out when Nipper assembly is farthest from the detaching rollers, so that it provides sufficient space for the cylinder comb needles to pass through the lap fringe without any risk of hitting the detaching rollers. In the diagram which you see is here, the detaching rollers are placed here and the Nipper assembly is here. So, the assembly keeps on moving backward and forward, and the cylinder is placed, cylinder comb is placed in between. So, what we do is that we want to avoid any chance collision between the needles of the cylinder or the Nipper assembly with the detaching rollers or with the cylinder needles. So, the Nippers is made to therefore oscillate, and it oscillates back and forth, and the oscillation, the movement, how it is generated, that we have learnt earlier, because the assembly is connected to the Nipper shaft, and this Nipper shaft, we all know that this shaft keeps on rocking, and as a result the links through which the assembly is connected is made to oscillate. The question arises that how to divide the duration of forward and backward journey times of the Nippers. As we have seen that Nipper, this assembly as a whole moves forward and backward. So, how much time should be given to the forward motion and how much time should be given to the backward motion? Usually more time is to be given for forward journey, as it reduces the velocity of the Nipper assembly and thereby air drag on the cone fringe of fibers approaching the detaching rollers. So, the Nipper assembly velocity we can calculate when it holds the fringe and moves forward at high speed. Then the fringe has a tendency to get buckled because of the resistance of the air. So, in order to reduce this resistance of air or the drag of air on the fringe, we will try to reduce the velocity while it is moving forward. The other thing is the drag also may cause, as written here, the leading edge to buckle, as I have already mentioned, and if the end buckles, then it will affect the quality of the piecing. Therefore, we make sure that the forward journey takes more time than the backward journey. The question that comes, that how much time we should give to the forward journey and how much time give to the backward journey. Typically, a ratio which is chosen is 60:40, that 60% time is given to the forward journey and 40% time is given to the backward journey, but ultimately the Nipper assembly is moving the same distance continuously backward and forward. So, if we choose a ratio of 60:40, which is usually chosen, then the forward journey timings is going to be how much? In the whole cycle, the whole cycle consists of 40 index number, is equivalent to 40 index number, and in one cycle we are supposed to complete all the operations. Therefore, the equivalent number of index or mark that we see on the index wheel for forward journey, if we give 60% time, that means it will be 0.6 into 40, that is 24, and for the backward journey the timing will be 0.4 into 40, that is 16. That means the way we set the machines, that the forward journey takes 24 index number and the backward journey takes 16 index number. So, if we look at this particular slide now, forward journey has to begin and has to end. Similarly, backward journey has to begin and has to end. So, the beginning of forward Nippard swing can be fixed arbitrarily at any index number to start with, and the rest of the timings can be set relative to this timing. This is, we have to remember that the beginning of the forward journey for the Nippard we can keep at any index number, and once we fix it, the rest of the settings for other operations or other elements can be set. So, in this case, let us say that TNFS is the starting of the Nippard forward oscillation, and TNFE, where N stands for Nippard, F stands for forward journey, and S stands for starting and E stands for ending. So, journey starts and journey ends. So, TNFS and TNFE, therefore, the starting of Nippard forward oscillations, ending of Nippard forward oscillations. So, TNFE, that the timing when the Nippard is going to stop its forward journey will be the beginning timing, that is TNFS plus 0.6 into 40, that is TNFS plus 24, where 24 indicates 24 index number. So, wherever we start, starting time plus 24 is going to be the ending time for the Nippard swing. So, the beginning and the finishing timing of the Nippard backward oscillation therefore can be written as TNBS will be, first of all, will be equal to TNFE, because whenever the forward journey ends, the backward journey starts. So, they must be equal, and the ending of the backward journey is the beginning of the forward journey, for beginning of the backward journey, TNBS plus 0.4 into 40, that is TNBS plus 16. So, this is how we can write, therefore, TNBE, that is when the backward journey ends, the forward journey begins, and this is moves as a cycle, because the cycle, the maximum timing is given is up to 40 index number. So, this is how we can write them, and if let us say the forward swing starts at 0 index number. So, TNFS is 0. So, TNFE is going to be 0 plus 24, therefore, it will be 24, and backward swing, for backward swing the TNBS is going to be TNFE. So, they will be same, and therefore, it will be also 24, and hence the TNBE, the ending time is going to be TNBS plus 16, which will be 24 plus 16, which is 40, and 40 or 0 both are basically same. So, therefore, we can say that the forward swing of the Nippard is from 0 to 24 and backward swing is from 24 to 40 or 24 to 0, because 40 and 0 are basically same, have same index number in terms of their values. If that way, if we set the timing of the Nippard swinging time, now we move on to cylinder combing time. in one cycle or one full rotation of the index wheel, that basically means one full revolution of the cylinder comb shaft, many operations have to be performed, as we already know. Cylinder combing operations is allotted 1/4 cycle time, which is equivalent to 1/4 of 40, that will be equivalent to 10 index number, because maximum we have 40. So, the combing duration represented by TCD will be equal to 10. So, 1/4 of the cylinder comb surface is therefore filled with combing needles. This part is known as half lap, and therefore, the entire surface of the cylinder is not covered by needles. Only 1/4 part of the periphery is covered by needles. And if we want to increase the number of needles which will be passing through the fringe, then we have to increase the diameter of the cylinder. That is the only way by which we can keep the angular rotation same, but we can have larger surface area if we increase the diameter. So, 1/4 part of the cylinder comb is filled with combing needles, and this part is known as half lap. Now, the question comes, how to choose the starting of cylinder combing, at what time we are going to start the cylinder combing operations. What is the criteria? Criteria is combing should be carried out when nipper assembly is farthest from the detaching roller, so that there is sufficient gap we maintain for the needles to pass through the fringe without having any chance of hitting the detaching rollers. So, it is carried out when the assembly is farthest from the detaching roller, that is during transition period from backward to forward journeys. So, nipper is continuously oscillating backward and forward. So, when it goes to the backwardmost positions and then reverses back, starts moving forward, that is the time when it is farthest from the detaching roller. So, that is the timing, therefore, we have to choose for cylinder combing. Since the combing duration is only 10 index number, this duration can be distributed equally between forward and backward swinging movement. So, while it is going towards the backwardmost positions and while it is just starting the forward journey, there this timing we can distribute equally for combing operation to be carried out. So, if we look at now this slide, let the starting and the finishing index numbers of the combing cylinder comb be represented by TCS. T is the timing, C stands for cylinder comb, S is the starting time, and E stands for ending time. So, look at this diagram. So, we can see that when the backward swing is about to be completed, which is somewhere here, we take 5 index number from 40 and we keep it for combing operations. So, if we read this now, TCS will be TNBE minus 5. TNBE stands for nipper end of nipper backward journey, that minus 5, and TCE, that the ending time of the combing, is TNFS plus 5, because we have divided 10 into 2 equal parts, 5 index number during backward swing and another 5 index number for the forward swing. With this logic, we can say now that TCS is going to be TNBE minus 5. So, TNBE, if we look at the diagram, it is at 40. So, it will be 40 minus 5, it is going to be 35. And TCE is going to be TNFS plus 5, and TNFS and TNNB are basically same, is going to be TNB plus 5. So, TNBE, that is ending of backward journey of Nipper. This value is basically 40. So, you can write 40 plus 5, that is 45, and therefore, we have to subtract 40 because 45 it has to pass through the index number 40, which is also equivalent to 0. So, to get the right value, what we do? We 45, from 45 we subtract 40, we get a value 5. So, therefore, what we can write, that the combing starts at 35 as it is shown here, it begins here at 35, that is here, it starts somewhere here which is 35, and then it goes on this side, it goes up to 40 and it moves forward. So, 40 is here, that means this 40 is basically here also for the next cycle, and it goes on while the nipper is moving forward, and how far it goes? It goes up to 5. So, we see that the cylinder combing timing in the present situation is going to be from 35 to 5, which is equivalent to 10 index number. This is how the combing timing is set. You go from here to the next operation, that is opening and closing timing of the nipper plates. So, there are two nipper plates, as we all know, there is a bottom nipper plate and there is a top nipper plate, and these two nipper plate, they are at times in open state and at times they are in closed state. So, we have to open and close them in order to grip the lap that we feed. So, nipper plates opening and closing process, it starts opening, then it opens fully, it keep closing, closed fully, and then it remain in closed state for some time. In any given cycle, this is what is going to happen. So, the opening is not going to, cannot take place instantly, similarly closing is not going to take place instantly. So, there is a duration of time over which the two nipper plates would gradually open and also they will gradually close, and there will be some time when they will remain in closed state only. Why they should remain in closed state only? Because it has to grip the lap sheet while the cylinder combing is doing its job. So, as long as the combing process is going on by the needles of the cylinder, we have to keep the lap sheet gripped between the nipper plates, otherwise all the fibers will be taken away by the cylinder comb. So, nipper plates have to remain in closed configurations for a certain time duration for gripping the lap sheet during combing period. Thus, the closed duration of the nippers is the cylinder comb duration, that anyway we have to keep, plus 4 index number we give it, is an allowance for safety purpose. That is, we should make sure that we grip before the combing process starts, and so that there is no chance that by the time the cylinder comb needle starts combing the fringe, the gripping remains incomplete. So, we keep some allowance so that we can start early and close a little late. So, therefore, this 4 index number is given to them. So, time available for opening and closing therefore becomes 40 minus TCD, duration of time while combing is going on, minus 4. So, more time, and now this is the time that is available for us for opening and closing operations. More time is given to opening than closing, so that the opening does not take place with a jerk. So, we have generally we open little slower, but close little faster. We follow the ratio of 60:40 here, instead of 50-50. So, opening of nippers, at what time we are going to start? The starting time will be any time after TNOS, that is the starting time of nipper opening. O stands for opening of nippers, should be TCE plus a time duration which is given, that is 3. This is just the allowance part. Similarly, ending time is going to be TNOE, it will going to be TNOS plus 0.6 into the duration which is available is 40 minus TCD minus 4, which I have seen earlier. We give 60:40 ratio, therefore, we multiply this timing by 0.6 in order to get the ending time. Similarly, for closing, time at which the nippers start closing is the time at what the nippers opening process is ending. So, TNCS and TNOE are exactly going to be same, that whenever the opening ends, the closing process starts there. So, they should be always the same timing, and the closing will continue over a little period of time. How long they will continue? That time will be TNCS plus 40% of the time available, for that is 0.4 into 40 minus TCD minus 4. So, this is how we can set the timing, and if I now give the values, if we put, then you see that the starting time of nipper opening will be any time after TNOS, therefore, it is going to be TCE plus 3, that is 5 plus 3, that is going to be 8. If you look at the diagram, it will be clear, that is the combing will be going on till index number 5. So, index number 5 is somewhere here, it is somewhere here. So, we can start the process of opening, we leave little bit of time, we can start theoretically, we can start right after 5, but we keep certain time and let we start, instead of 5, we start at around 8, that is somewhere here, which is actually going to be 8. In present case it is 10. So, it could be any time after 8, it will be 8 or 9 or 10, though theoretically it is possible to start even at 5, but 5 we have to avoid because there is a chance of collision or interference between the two timings. So, we do not keep it at 5, we give little time which could be 8 at least. So, we can start actually opening at 8, but we can also start at 9 or at 10, it does not matter, it has to be after 8, any timing after 8. The ending time will be how much? If we put these values here, TNOE, nipper opening going to end, is TPOS plus 0.6. So, it is not POS, it will be NOS, this value, plus 0.6 into 40 minus TCD minus 4. So, if we put these values here, so you will get it is 8 plus 0.6 into 40 minus 10 minus 4. So, it will give you a value 8 plus 0.6 is 26. So, the value is going to come is actually 23.6, which is equal to 24. That means, the ending of the opening when it will be fully open will be around 24 index number. So, nipper starts opening here when the number is around 8 and it closes here, that is around 24, and when it remains completely opened here, that is gradually opens. So, here it is fully open. Now, at this point onwards it starts closing. So, nipper closing time if we look at it, so opening time ends at 24, that is here, and start closing here. So TNCS and TNOE will be same as we have already stated earlier, and when it is completely closed, we can work it out. TNCE is TNCS plus 0.4 into this value as we have seen it earlier, and if we put those values, we will get it 24 into 0.4 into 26, which will give you a figure 34.4, that is close to 34. That means at 24 it starts closing and it completely gets closed at 34, which is here. It has to be closed by 34 because by 35, if you 35 I have to start combing. So before the combing operation starts, the nipper must close. If we start combing at 35, we must close the nipper by 34 or by 33. So we can also close it at 33 or 32 also, but in that case the closing will be very fast. So we have a timing available between theoretically between 5 to 35, when I can gradually open the nipper and then gradually close the nippers also. That is the time which is available, but to avoid any chance of collisions or any interference, we restrict the time between 10 to 34 or maybe 10 to 33. It may be set also between 10 to 33 as well. There will not be any problem. Next, we go for lap feeding timing. Now here there are two types of machines. One is lap feeding during forward journey of the nippers, and the other one is during the backward journey of the nippers. So let us see what are the conditions that need to be met if we want to feed the lap while the nippers are moving forward. So feeding should be completed during forward oscillations of the nipper. So we know that what is the forward oscillation timing for the nippers, and that timing is basically between 0 to 24 as you have seen earlier. So that means we have to feed the lap between 0 to 24. That is the first point. So the second thing is nipper should remain in an open state during feeding. While in feeding the lap sheet, the nipper should not remain in closed state, otherwise the fed lap will get piled up behind the closed nippers. So we have to also make sure that the nipper should remain in open state during feeding, that is in between TNOS and TNC, that is 10 plus 2 to 34 minus 2, that is between 12 to 32. This is another conditions that we have to meet. Feeding should end prior to the commencement of cylinder combing process, that means TCS, which is basically less than 35. So we have to make sure that the feeding ends before 35. So these are the three conditions that we have to meet, so that there is no interference and there is no problem with the process of combing. And if we meet these conditions, then we will find that the timing which is available to us is basically when the nipper remains open. So nipper, as you have seen, nipper opening timing, it starts from 8 and it goes up to 24. So this is the time available for feeding the lap sheet. So we can actually feed the lap sheet any time between 10 to 24. So what is generally done, that the little feed that is required, we start at 13 and we finish by 24. So 24 the nipper is fully open and we have time available equivalent to 13, 24 is 11 index number for feeding the lap sheet. So, we cannot start the feeding process earlier, because if we go less than 10, then the nippers are not open. In that case, the lap sheet is going to be piled up. So, keeping in mind all the three conditions that we have stated earlier in the previous slide, the time which is available for us for feeding the lap sheet will be somewhere between 13 to 24. We can also start at 11, but we are just keeping make sure that the nipper is open a little bit by the time we start feeding the lap. So, instead of starting at 10, we start at 13. We make sure that by 13 nipper is already open to some extent. Now, lap feed during backward journey of the nippers, because there are machines where the feeding timing is changed due to some other reasons. So, in backward feed, the conditions to be met. What conditions? First is feeding should be completed during backward oscillation of the nipper, and the backward oscillations of the nipper we have to see at what time it starts and what time it ends. So, the backward journey and the ending journey. So, if we the backward swing starts at 24 and goes up to 40 or 0. So, the backward journey should start at 24 and it will go up to 40. The nipper should remain in open state during the feeding, that is TNOS and TNA, and that time if we go it will be 10 plus 2, that is up to 34 minus 2, in between 12 to 32. And feeding should end prior to the commencement of cylinder combing, that is before 35 we have to end feeding. So, the oscillations is going to start at the backward journey starts not really at 0, it should start at 24 and go up to 40 or oblique 0, because 40 and 0 are basically same. So, backward journey begins at 24 and it is carried out till 40. Now, if we follow these three conditions, then the time which will be available to us is that backward journey starts at 24. So, we have to start the backward feed around 24 or 25, but we have to make sure that we have to close it before 35. So, during this journey if I draw a line, then we can it will be clear to us that this timing is definitely starting after 24 when the nippers are about to close, but not fully closed. So, during this journey we can feed the lap when the nipper is also gradually closing, but still it is not fully closed. So, before it is fully closed, that is by 32 the feeding is over. So, we can feed from 25 to 32, we do not wait till for 34. Prior to 34 we end feeding, because from 35 the actual combing is going to start. So, we must make sure that the feeding ends before 35, and not only that, the feeding must end by the time the nippers are fully closed, that is before 34, and hence timing is given from 25 to 32. We can go up to maximum 33, we cannot go beyond that. The other movement is detaching roller movement. The diagram is given in the right hand side about detaching rollers. And detaching roller movement we have already discussed earlier some other lectures, that the detaching rollers rotates in backward and forward directions, that you all know. This is what is required in order to piece the comb fringes. The time allotted for forward and backward rotation is 50%, that is equivalent to 20 index numbers. The total number of index numbers are 40. So, we give equal time for forward rotations and backward rotations, and therefore, we give almost for forward rotation almost 20 index number equivalence of time, and for backward rotation also similar. The time allotted for forward and backward, sorry, the time allotted for backward and forward rotation combined is 50%, that is equivalent to 20 index number. So, 20 index number is meant for both forward and backward journey, not only for forward or not only for backward. Combined timing required to complete the forward and backward rotation is 20 index number. And now, for forward and backward rotation, the time is divided equally. That means, we give 10 index number for forward rotations and another 10 index number for backward rotations. This is how the detaching rollers are made to rotate. So, if we look at this diagram, here we have drawn the diagram for two consecutive cycles, first cycle here and second cycle here. Two cycles we have drawn, so that understanding becomes clear. And what we see here, condition to be met for detaching roller movement, that when we should start the detaching roller movement and when we should close. So, two types of movements are there, backward and forward. Backward rotation, we have already explained earlier the why it has to rotate backward, because it has to feed back the already detached fringe of the previous cycle. So, the tail keeps hanging from the nape of the detaching roller, and then the forward part of the cone fringe of the present cycle is going to land on the tail part of the fed back fringe from the previous cycle, and therefore, there is going to be a piecing. It was discussed earlier. So, we need both backward and forward journey, and condition to be met, it should be during forward motion of the nipper assembly, because detachment can only begin when the nipper's assembly has come closest to the nipper. So, this is one condition, that is it should be during forward motion of the nipper assembly, that is TNFS and TNFE, that is between 0 to 24. The second point is detaching operation can start only after combing is over. So, we have to make sure that we cannot have detaching between the timing 35 to 5 while combing is going on. So, this is the timing when we have to always avoid, that is after TC, that is index number 5. Only after that. So, time available is from 5 to 24. If we look at this time, the time available is therefore 5 to 24, that is equivalent to 19 index number. So, backward rotations of the nippers of the detaching rollers starts little late than 5. If you look at the timing of backward rotation, it starts somewhere here, which is not exactly 5, little late. By the time 5 the combing is over, now the nipper assembly is also moving forward, so that the fringe can be detached. So, before the cone fringe reaches the nape of the detaching roller, the detaching roller starts feeding back the previous fringe. So, it must start rotating backward. So, it starts somewhere at 7 and it continues its backward journey. How long? That is up to another 10 index number. So, it starts at 7 and it must therefore end at 7 plus 10, that is 17, so which is going to be actually 17. So, it starts at 7 and ends at 17. That is the backward journey of the detaching rollers. Now, the forward rotation starts. It starts at 17 and goes till how long? Because we have divided the time into equal parts. So, another 10. So, it can go beyond, that means 17 plus 10 is equal to 27. So, it can go beyond 24 as it is not going to interfere with any other motions, and hence it can go even up to 24. There is no problem beyond 24 because it is not going to interfere with any other motions. So, this is the backward journey from 7 to 17, and 7 to 27 is the forward journey for the NIP, for the detaching rollers. So, that is how the rest of the timing, if you see, for 27 to 7 of the next cycle, 27 to 40 and from 40 to 7 of the next cycle, the detaching rollers are almost stationary, not really moving much, it remains practically stationary, and again the next cycle begins and similar movement takes place. So, detaching roller keeps on rotating forward and backward, and the timings can be set in this way. Now, we come to the top comb timings. We all know the top comb has to perform the job of combing basically the trailing part of the fibers which have been combed by the cinder comb needles already, but we will also see that it has another interesting function also, we will discuss sometime later. So, in this case the top comb timing, the conditions to be met, top comb should penetrate only when the detaching process has begun. This is very, very important. That is, it must penetrate only when the detaching process has started. Otherwise, if it has not yet started, if it suppose the detaching process has not started and the fringe is held by the nippers, the top comb descends. In that case, what will happen? The fringe is going to buckle. Forward end of the fringe is going to buckle, and therefore, it will disturb the piecing process. The piecing quality will suffer. So, you have to make sure that the top comb will only descend when the forward end of the fringe, comb fringe, has been gripped by the detaching roller nip. Therefore, what we do that TPS must be greater than or equal to TDFS. So, TPS is top comb penetration time starting. That means, it has to be beyond 17. At 17, the detaching roller starts moving forward. So, the top comb penetration time should not be exactly 17. To be on the safe side, it should be little more than 17. It should penetrate the fringe only when the front part of the comb fringe has been gripped, as I have said already. Hence, TTPS is going to be TDFS plus either 1 or 2 index number. So, TDFS is basically 17. So, it will be 17 plus 1 or 17 plus 2. Hence, the timing is either 18 or 19. So, you see the timing of the top comb that we start the action of the top comb on the fringe around 18 or around 19 we can start. How long we will continue? We will have it there. The duration should be till detaching process is going on, subject to beginning of the cylinder combing in the next cycle. So, we should hold the top comb there, still the detaching process is going on, and therefore, we should hold it there how long? Till the next combing for the next cycle begins. So, the maximum timing that you can hold is up to 35, but generally we keep it up to 31. So, 18 to 31 becomes the top comb penetration, and it remains within the fringe. That is the duration when the top comb is really playing its role, and that is how the top comb timing and withdrawal from the fringe is decided. And with that, we end this lecture on the lesson on this timing diagram of various operations of comb burr. And therefore, what we see is that there are quite a few operations, and these operations are somewhat linked, that is, they have to take place in a certain order, and we have to always maintain that particular order. And if we can't maintain, then there will be interference between the operations, and as a result the combing may not be performed properly. And the index wheel is of great help to the engineers who are working there, because it is going to help the people to set the different elements of the machine, so that the operations which are there, they can be performed in a very, very systematic manner and in a predetermined sequence. With that, we stop this lesson. Thank you.